The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Making Varied Digit Adjustments in the Decimal Parts, Part 1. In the exercises so far, we dealt with the decimal parts having same digits, in which case same types of adjustments had to be made in the decimal portions. We also used examples where one of the numbers had adjustment and the second number was not altered. In the current example, let us see how the adjustments are varied in terms of the number of digits in the addition process. Let us see how this can be done using the example 42.3524 plus 26.42318. In this problem, the first number has 4 digits in the decimal part, whereas the second number has 5 digits in the decimal part. Before making adjustments, we have to convert the decimal part into same number of digits, and therefore the first number becomes 35240 and the second number remains the same as 42318. The adjustment technique involves converting the last 2 digits of the decimal portion into its higher digit value. Here 352 are the first 3 digits of the decimal portion and 40 are the last 2 digits. We can convert 40 into multiples of 100 and add it with the 2 of the decimal portion. That is, 2 can be increased by 1, thus making the 4-digit number as 353. The meaning is that we have added 60 to the 40, making it 100, which means the one with existing 352 makes the number 353 and the last 2 digits as 0. Likewise, let us take the second decimal number, in which case the decimal portion is 42318. Let us convert this into 3 digits. That means it becomes 424, indicating that we have added 82 to the last 2 digits 18, thus making the last 2 digits as zeros. The adjustment indicates that we have added 82 to the second number to convert it to a 3-digit decimal part. The meaning here is that we have added 60 to the first number and 82 to the second number, and therefore the total 142 should be subtracted from the final result by treating the decimal portion having 5 digits with the last 2 digits as zeros. With this process, we have converted the 2 numbers as 42.353 and 26.424. Let us consider this as whole numbers and set it from the right extreme of the abacus. That is 4 in the units column, 2 in the tens column, 4 in the hundreds column, 6 in the thousands column, and 2 in the tens column. Let us set the second number at the extreme left of the abacus for reference. That is 4 in the extreme left, followed by 2 and then 3, followed by 5 and finally 3. Let us add 4 with 2, that becomes 6. Let us add 2 with 6 and that becomes 8. Let us add 3 with 4 in the hundreds column, that is add 5 in the upper abacus and clear 2 in the lower abacus. Let us add 5 in the tens column and finally we have to add 3 in the units column. That is add 5 in the upper abacus and clear 3 in the lower abacus. We get the result as 68,777. We can notice that the dot on the separating bar is distinguishing the whole number and the decimal part. If you reconvert the result into a decimal number, the result we get is 68.777. As we converted the varied digits decimal parts into 3 digits by making the last digits as 0, we have to take the number as 68.77700 for making the final adjustment. We already mentioned that in making the adjustment, we added 60 to the first decimal number and 82 to the second decimal number. That means we have added 142 in the conversion process. That should be subtracted from the decimal portion of the result, which makes the number as 68.77558. As subtracting 142 from 700 gives 558 as the last 3 digits. In case the child needs assistance in subtracting 142 from 700, that can be treated as a separate problem using abacus, and then the result can be noted. In the current example, we used different numbers of digits in the decimal portions, and therefore the process required more attention in treating the number of digits in the decimal portions.